Right, I'm just going to do 3 problems from this exercise 6E1, and we'll do question 3, question 8A and 10A. You should try the rest of the question from this exercise. Right. Now they ask you to find dy dx. Okay, so we do that. If you recall that to find the dy dx of this function is simple. Just differentiate 2x plus 1. What do you get? Right, 2. Write the 2 here, and just copy the whole thing after 2. There you have it. Now, so that means if you integrate this, and we know that means this is the antiderivative of 2e to the power of 2x plus 1. So that means if you integrate that, you get e 2x plus 1. Now, and you probably recall from exercise 6D that you must always add a constant. We do not know what that is. It's fine, we just have to write plus c. And however, the question asks you to get this and not 2 e to the power of 2x plus 1. So we do this, we should be able to factor this. Dx, write the 2 in front and put it right in front. Okay, and what we do is going to times half across the whole equation, and then thereby cancelling the 2. Okay, and you have a half e to the power of 2x plus 1 and half c. Well, half c is just another constant. I'm just going to replace it with something called c1. I just make it look nice. It wouldn't really affect the result because it's just a number, but so there you have it. This is the outcome if you integrate this function. Now moving on to question 8a, right? Find dy dx if you given this. Okay, fine, just do it, dive into it straight away. And if you recall, you have something like this, and when you derive this is y. The dy dx would be ax plus b. There will be n here, and this is n minus 1. Okay, so this is a formula to that. Dy dx is 6 times 2. Is what we're going to do is we derive this respect to x. You get 2. So you have 2x minus 1. This is 6 minus 1, so you get 5 here. And so you have 12 2x minus 1 power 5. And so they ask you to find this, and therefore this 2x minus 1 to the power 6 is the antiderivative of this expression. So meaning that if you integrate this, you should see this. Again, do not forget the c. However, we are being asked to find the integral of 2x minus 1 power 5 without 12. We do this step. And yet again we multiply by 1 over 12, and thereby cancelling this. Okay, and so we'll end up with this. So we have 1 over 12 2x minus 1 power 6 plus a c1. C1 is just another fancy constant, we use to replace c over 12. Right. Okay, then moving on to question 10. pen right here. We get a pen on. So fine, I ask you to consider this. So well, just why not? You know, they ask you to do that. And if you recall differentiations of exponential function, if you differentiate like e, that's a function fx, and so what we do is we differentiate f, and you have df dx. Okay, you write that in front, and you just copy the whole thing here, right after df dx. And so in this case, you differentiate x minus x squared, you get 1 minus 2x. Is that okay, right? And then just copy this, and there you have it. And that means that this e to power x minus x squared is the antiderivative of this expression. And so when you ask you to do this, this will be e x minus x squared. Do not forget, no matter what, unless it's a definite integral, that means you see numbers here and here. Now you don't see numbers here right now, right? So you must add a c. This is a must. You cannot forget the c. And just in case you don't see this, I just switch the position of this 1 minus 2x, and that's why when we integrate this, we'll get this expression, this function, that is, and plus c. And remember the c, this is always remember, you must put the c after integration.